welcome everybody. How's everybody doing? Good morning. I hope you've all been enjoying Rails Conf. It's been a great conference in my opinion. I want to thank Ruby Central for putting it on. It's been a top-notch production. I also want to thank each one of you for coming to this presentation today. I also want to thank you for sitting, because this is the only time that I'll be taller than any of you. Before we dive in, let me introduce myself a bit. My name's Trevor. I work for Amazon Web Services. I've been there for a little over 2 years now. I have the good fortune of working on open source for AWS. You may know me if you use the AWS SDK gem. This is the official Amazon Ruby SDK gem. And I also am a contributor, and both of these I work together with Lauren Siegel, right over here in the front row. Lauren is also the maintainer of Yard. So together we maintain the AWS SDKs for Ruby and Node.js. Managing an open source project can be rewarding and challenging. It can be a little chaotic, much like herding cats. But this chaos is something I feel uniquely qualified for, not because I own 3 cats, but because I'm the father of 5. So these are my kids, Simon, Boston, Audrey, William, and Dean. Thank you. And I will pass that applause on to their mother who's at home in Seattle with them right now, taking care of them by themselves. So let's dive in. Let's talk about APIs. Wow, that's really, really, ominous there. Let's fix that. This brings me back to my childhoods in the late 80s, early 90s. So maybe this will put me a little more at ease. My presentation today will be touching on concepts and topics that apply mainly to building web services using Ruby and Rails. That said, much of this material is very applicable if you're building websites using, Rails. But we're talking specifically about web service APIs. As you might know, AWS is a strong proponent of building everything out as a service. AWS has over 30 services today. We just launched another one last night, AWS Support API. And this is just something that's kind of ingrained. You may have also been noticing the general convergence of the Ruby and Rails community towards breaking apart that monolithic website, the monorail or the monolithic Rails application into smaller, dividable chunks. I think this is definitely the right move. And I also hope I'm not the only one who's kind of noticed this unstated theme of this conference, that we are using and moving towards Rails as an API platform. There's lots of good reasons why we should build APIs. They're smaller, more focused. Web services are easier to deploy and manage when they are separated. They're easier to provision and scale. But I'm not here to sell you on this concept. The main thing, if you really walk away from this presentation taking only one message, it's that APIs, or your API, should be an entity, but not a side effect. And what do I mean by that? Generally, when we start a new greenfield project, we Rails new, and then the very first thing we do is we generate a database model and run rakedb migrate. We might even drop down to Rails scaffolding if we want to just get this up real quick so we can bang out and iterate and see things go back and forth. And this is very satisfying. This scratches that itch or that need inside of us to see things work. It's like getting an achievement. Yay, achievement unlocked. I have a basic CRUD application. The problem is when we do this, we're really approaching our APIs backwards in the wrong way. We need to be approaching our APIs not from the data persistence layer, but from the actual API that our customers are going to be interacting with. It doesn't really matter how good looking we can shape our JSON documents and whatnot. If they're being driven by the database model, we're going to be setting ourselves up for some disappointment later on. We learn these same messages from other angles inside the community. BDD and TDD proponents, they teach or they profess that we should think about the outside in. So how do we apply this when building an API? If I were to take the MVC pattern, which is a strong pattern in Rails, and apply it to a web service application, I would probably just naively say, well, models, that's my database layer. Views, those are like the JSON translation I'm doing on my data. And then the controller is all that stuff that just kind of glues it up together. And that would be mostly correct. I say mostly because your model is doing too much. And this is a common theme. We tend to try and cram too much into the model beyond just basic business logic. I've been working with Rails for a long time. I started back in 1.16. This was, gosh, it was like 7 years ago. And I remember seeing Rails kind of mature through a couple of different themes. One of the earliest problems we had was we were putting too much in our controllers. And so there was this move towards fat models. It's like, your controller should be thin and lightweight, and you need fat models. And then that kind of the community matured beyond that. And they said, hey, your models are now doing too much. They're taking on too much responsibility. And they're right. What they're noticing is that your model is doing not just the data persistence and guarding your remote, whatever you use for storing data, but it's also defining the shape of your API. And remember that statement, your API should be an entity, not a side effect. It shouldn't be a side effect of the structure that you use with your backend. So does anybody here know who said this quote? Okay. Probably not. I would love to say that this quote originated from some really clever fellow, but it was really just me writing my speaker notes. So the shape of your API should be driven by your domain model, not your persistence model. So if you conceptually want to take that model and split it into two parts, the part we want to look at is the data as it comes in and to your application and how it flows out, but not what you do with it once you have it. Okay? So I'm going to use terms like types and shapes, but that's really what I'm talking about. So why do you need an API model? So I've kind of danced around what it is, but why do you need one? If your API model is not document-driven, if you don't actually have an entity that describes it, you are going to be duplicating a lot of effort. You're going to code stuff up, and then it's like, okay, now I need to build API documentation. Or now I need to filter incoming request parameters. Or I need to convert these scalar strings that come across in the JSON document to meaningful types. Or I need to generate clients. And lastly, as a side effect, I forgot, I might need to version my API. And all of these things are harder if you don't actually have a physical description of what your API is. So I'm almost 8 minutes into my talk, and I haven't even mentioned what Seahorse is. So let me give you a quick definition, because a lot of you probably came here going, Seahorse what? Seahorse is a model description document. It describes the shape of your web service API. I do want to point out, it does not dictate the protocol that you use. It doesn't describe whether I'm using XML over the wire or RESTful JSON or just the simple RPC protocol. That's not its goal. It is, it's also something that we extracted from our work building clients for AWS. I work on a team of really smart engineers, and despite all of our cleverness, it's very difficult to handwrite a client for 30 different web services for AWS, and each one might have 30 to 100 different operations, and each one might accept 20 or more parameters and return very complex shapes of data. It just does not scale. And so we went very quickly to this idea of we're going to have a description of these that we can share amongst ourselves. PHP, Python, JavaScript, Ruby, and we're going to consume the same common description, and we're going to use it to generate our docs, generate our clients, do a lot of interesting introspection that you could not do without that document. Interesting, Seahorse actually is in the wild. If you've used the new AWS Python CLI, if you haven't checked it out, I highly recommend it. It internally is using Bodo Core, and Bodo Core uses Seahorse. The new PHP SDK also consumes these Seahorse model documents to produce its own guzzle service descriptions. The new Node SDK that we launched, which now has full service parity across all of AWS, also uses this. And I put Ruby down there. We don't actually use it yet. This was extracted from our original Ruby SDK. We are going to be revving to a version 2 that consumes Seahorse documents directly here in the near future. So let's go actually see what a Seahorse... so right here, if you were to go to... Actually, let me bring up a browser. We just pushed this morning, so GitHub AWS Labs Seahorse. The tech demo that I'm running today is available there. It's also available as a gem install Seahorse. This is an early tech demo for the Rails eHalf, but it also has the DSL for building Seahorse model descriptions. So let's go see. Here's the actual code. It's a tidy, about 600 lines of code. There's lots of interesting things that we can add here right now. But you'll see there's all your basic types in there. Let me open up. So this is a demo Rails app that we called Newsfeed, kind of like a Twitter stream. And inside of it, we have app models, and we just put them here under API. And let's take a look at the user one. So can everybody see that? Is that a good size? All right, so basically what you've got is the concept of types. Sometimes I might say shapes, so types and shapes, I mean the same thing. And then you've got, so you have complex types, scalar types. Types can inherit from things, so up here we name a type username so that we can reuse it in our model definition. But it inherits from the type string, so we have a bunch of basic types. Down here we might also then start defining operations. And operations are really just it's an input and it's an output. And the input links to a type, and the output links to a type. And that's really what you're doing, is you're actually defining what all these things look like. The DSL, if you were to rake Seahorse API, looks like this. So it's a JSON document. At the top level you have operations. Operations have names, and they have inputs and outputs. And they may have other arbitrary metadata merged in on top. So there's not really much magical. It's very human readable. I'm going to come back to this and do more demoing, but I just wanted you to see kind of what Seahorse provides. Before we kind of move on, Seahorse is supposed to kind of fill a niche that is not really well scratched by Rails itself. Rails does not really provide you much building a web service API. This is unfortunate. There are lots of third-party projects, I'll mention some of them towards the end of my presentation, that do a lot of the same things differently than Seahorse does, but towards the same end. Little history, if you've been building Rails for a while, you're probably familiar with attribute protected and attribute accessible. These were introduced back in the Rails 2 era, and they were there kind of to fill as kind of a stopgap for some security issues, where bulk attribute assignments is kind of what is the bread and butter of a Rails controller, and they're inherently insecure. In Rails, I believe it was, I think it was 2.3. No, it was 3.0. They added the concept of attribute accessible as a role. And this it gave you a lot more flexibility that you could kind of define the shape of what attributes your API might accept. And you could assign these to different roles so that in your admin section of your website you might accept more. But I never want to accept the created attribute or whatnot, and so on. In Rails 3.1, they made a bold move to enable whitelisting attributes by default. This unfortunately caused lots of confusion in the community. There are over 7,000 Stack Overflow questions related to attribute accessible today, and it's a common problem. The issue is whitelisted attributes. They don't do enough, and they don't do it in a very good way. First off, they're tied down to your data persistence layer, which is not really where they belong, as we discussed. They don't I'm sorry, early versions didn't support multiple configurations. They obviously do now. And it's ugly to use with other, Rails conventions like nested attributes 4. Rails 4 to the rescue. I've been kind of generally surprised there has been relatively few talks that have presented new technology that's coming with Rails 4. So I'm going to take just a quick moment and introduce one that all of you should know about, which is strong parameters. Quick show of hand, how many people have used the strong parameters gem? Okay, good. It's been available since Rails 3.2 as a gem plugin that you could install to your Rails application. Rails 4 actually merges this into core, and this plugin is kind of a beefed up replacement for attribute accessible. It might look just like this. So here's a plain vanilla, absolutely empty. I just Rails new this application. I'm going to go ahead and generate a scaffold for a widget, and it's going to have a name and a secret. This would represent some, I'm using scaffolding for time concerns here. And I'm going to open up my widgets controller. Scaffolding now at the bottom does these widget params. What this is doing is action controller parameters now can no longer be bulk assigned into your ActiveRecord models without raising an error unless you've kind of permitted or filtered them. So calling require and permit in these cases kind of sets up some basic, API requirements, if you would. And in this case, I don't want people to bulk assign secrets, so I'm going to remove it from here. And in practice, we can now see this work. Oops. And of course, new application, RakeDB migrate. I knew I was going to forget something. Okay, this brings up my scaffolded widgets controller, and I'm going to add a value. And because secret is filtered and the behavior is set to just ignore, you'll notice that it did not bulk assign secret. And it actually goes one step further. If I'm a lazy programmer or I'm not using scaffolding and I forget about this, so I'm not going to use the widget params. I'm just going to pass my params into my bulk assignments. When I run that same code, I'm actually going to get a forbidden attributes error. So you just cannot flat out use params without it. So this is great, right? I mean, we should all, one up for security, but there are, it's a little unwieldy to use. This is taken straight from the GitHub README for the strong parameter site. Does anybody off the top of their head know kind of how that DSL reads or what it means? I mean, it's kind of a little awkward. The emails hash rocket empty array, what that means is that emails is a property of kind of your top level hash, and it can be an array of scalars. And strong parameters define scalars fairly loosely, but there are some interesting limitations with strong parameters. Primarily, the complete absence of type information. Without type information, it's not possible to differentiate, for example, between different scalar types. Strong parameters allows through strings, symbols, nils, numeric, booleans, dates, times, I/O objects, files. And this is really cumbersome to me because that means further down the line, even though I've already filtered it strongly, I then have to filter it again to make sure I'm working on a type that I expected. Like that they didn't pass me string ABC when I, or they didn't pass in nil when I was expecting a date. That's a terrible problem to get nothing when you want a date. Okay, that was a bad joke. This lack of type information also makes it impossible to do any intelligent type coercion on your parameters, which again means you're going to have to, even though you had that pretty DSL up there, you are going to have to kind of replicate that logic so that you can do any type conversions you might need to do. So right now, I'm feeling kind of strong, maybe stronger parameters is the better word. But it gets worse. Parameter filtering isn't sufficiently detailed enough that you can delineate the difference between, hashes of arrays and arrays of hashes and all these other different things. It's just not quite there. It also has some glaring omissions. It's not possible to describe with strong parameters any kind of user-definable map. And what I mean by that is a hash or a structure where the keys are provided by the user. Because of strong parameters, it's not possible, for example, to get a hash with user-provided attributes. And so this makes it very limiting, not without just blindly permitting, which, again, makes your system unsafe. So, and lastly, strong parameters are not very portable. They have requirements on action controller. So before you can try to reuse your crafty DSL that you built up there anywhere else, you would have to bring in action controller. And so it just gets to be a little heavyweight. So I'm kind of bummed now about strong parameters. And we're going to call them weak parameters. So it's not fair to kind of rag on something without providing some alternatives. And I think really what the alternative is coming up with a type-safe map or description. So this Seahorse DSL does this very simply. It introduces 3 different complex types: structures, maps, and lists. It introduces a handful of scalar types that are user-definable, so they're extensible. You can add additional scalar types. And then it also allows you to layer metadata on top of this. Let's see what this looks like just in practice. Structures are very straightforward. In this case, I've defined, again, the DSL will do much of this work for you, but if I were handwriting the JSON document, this would be the Ruby hash I'd use. A structure, it's type of structure, and a structure has members. Those are the possible maximum set of allowable keys. And in my example data, I'm passing in something. This would validate name John, age 40. Lists, like structures, have members. They're also a complex type. Lists and structures are very similar. The primary difference is lists only have one child type. They are homogeneous, meaning they are all of the same type. And then here's some example data: ABC, MNO, XYZ. Notably, all of the complex type members can be complex types themselves. Maps, in this case, Seahorse map has a defined keys and members. So this is the one where the user gets to define their own possible key set. So by defining it this way, it makes it possible that you can put constraints on what those keys are. You can set maximum lengths. You can say the keys should be numbers or the keys should be strings. And this now makes those user-definable maps type-safe. Example data, in this case, the user can make up anything as long as it fits that description, where on the left side of the hash, or the hash keys, are strings in this case, and the right side are strings. If I flip that map around, I could say it's strings to numbers or vice versa. The default scalar types, so anything where you saw integer or string in those descriptions, you could also add in other types, date times, timestamps, booleans, blobs, whatever you like. So this is the building block of a very extensible description of what your parameters look like as they come in and go out of your system. On top of that, I mentioned once before you can add metadata. I'll go back to the demo and you'll see what we do with this, but we layer some documentation metadata on these types, which we will build some docs with, and also validation. This is really kind of where it gets powerful. You can also, if you're building RESTful APIs, you can provide HTTP binding, like this parameter is going to end up in the headers, and this is the header name that it might be. So going back to why you need an API, let's kind of recap some of these. Filtering incoming parameters, performing parameter type conversions. Once you have that document, you now actually have something you can crawl, something you can introspect at runtime even if you wanted. You could statically generate from this. But it's something that now you're not having to try to go describe a database and try to infer from which columns are public and which ones are not. You also can generate comprehensive API documentation. I'm going to show you one of the cool things that we've done with this. So right here, this is the API documentation for the AWS SDK for Node.js. This is built using Yard, a small plugin to Yard, so that we could document JavaScript. It's really cool here. So first off, let me pick a service like DynamoDB that's got some interesting things. In this case, all of this documentation is pulled straight from that model, and you can have arbitrary amounts of documentation. And we just use it to dynamically generate these docs. The beauty of this is, if DynamoDB were to make a major revision on their API, which they have, we can actually copy this model over to a separate file, version it by name, and now we can generate old and new docs, and we don't have to worry about trying to keep our code in lockstep. This is an incredible time saver, and it eliminates a lot of interesting classes of bugs because we're not having to try to duplicate this domain logic in multiple places. Our documentation is with our service description. So in practice, let me just show you Models API. So in here, you can notice there's operation level documentation and input parameter level documentation. If I were to open up the newsfeed, so we just generated them into here, the newsfeed API, if I go to create post, you can see that's where the documentation appears. Creates a new post, username for this post. If you reuse the username type anywhere else in your documentation, that trait's going to follow it along. If you annotate it as required, Yard will pick that up and mark it as required. So there's all kinds of really nifty things you can do with this. Let's move on from documentation. So this is probably what I'm most excited about. If none of these other benefits really applied, one of the best things is once you have a strong description of your service, you can now generate or drive a client dynamically with that. The Ruby SDK v2, which is still a work in progress, it's not released yet, it will consume these directly, but as I mentioned, there's like 4 other SDKs that are live today that consume these live. And I want to give a little fun tech demo of how this might work. So this is the, first off, app controllers. So this is a simple Rails controller where we include the Seahorse controller. Well, that is kind of off the top of the screen, isn't that? It looks just like a generalized controller. The actions are mapped to the operations of the same names. You can go the kind of more RESTful route, and it will create RESTful route bindings for you, or you can kind of go the more RPC route and call your methods like create post. I mean, there's lots of alternatives there. But you notice there's not a lot of interesting things here, like I'm just using params. And you'll also notice I'm not driving, this is a Rails 4 application. Where is my strong parameters? Like, why won't this throw a bunch of errors? Well, that's because the Seahorse controller module, once you mix it in, actually will load up your API configuration and will actually crawl it and then build up the strong parameters for you. It does all that work for you. That means when you get the params hash, it's actually already been filtered. Next thing it does is it actually converts all the types. It looks at the model and says, hey, this is supposed to be an integer. Great, I'm going to typecast it to an integer for you. This kind of clobbers a whole classification of errors where I might try to do arithmetic operations on something that's a string. If it was passed in as a string, over my, like, let's say the protocol was XML, and so everything comes out as a string. Also, you'll notice I'm not doing any fancy jiggery pokery here for, so if I do or def shell. There's nothing interesting here in the respond with. The respond with is just, I'm passing in an instance of an ActiveRecord object in this case, and it's using the Seahorse DSL to figure out what attributes and what associated attributes, going down the line, it should pull off into the JSON. So nothing more than what you defined as your API makes it out. That mapping doesn't have to happen. I could actually pass in respond with and pass in a plain old hash. That there's all kinds of interesting things you can do there because you have a document that describes what you need to return. You can annotate it with how you want to extract it from your models and what models to extract from, but it generally is only possible if you have that document. So let's fire it up. Actually, let me just show one thing. Config routes. So, and this was the other thing that I thought was really nice. As your API changes, there's no need to go update it in lots of different places. It eliminates that manual duplication step of updating your docs, updating your clients, updating your route configurations. As your models update, you will get dynamic routes from it. Right now we have it generating probably more than we need. In order for this tech demo to work, I wanted to be able to do everything through a browser, which means I needed kind of RPC-style routes in addition to the default Rails RESTful routes. So you'll notice each one of these has a get version alongside the more RESTful verb. But that's going to allow me to do a few things like this. So in this newsfeed application, the idea is I'm sending in something that's JSON-like, and then I'm getting something back. Since the browser does a GET request, I can also do something like get username Trevor. This is the same thing because it's parsing my parameters, and then from there, Seahorse does the rest. And it's pretty cool. You can do all kinds of things like list posts, and we get everything back as expected. And that's pretty cool, because I didn't have to do a lot of wiring right there. But it doesn't stop right there. Let's take a look over here. So this is the new AWS CLI. Supports a whole bunch of different AWS services. But I've got a little wrapper script that just loads up that service.json file that you saw me rake generate that's symlinked into the Python Bodo core piece. And now I can do interesting things like AWS CLI, get username Trevor. Bam! And we're done. So literally, I took the Seahorse model with no extra coding, and I've got a CLI for it. Any Seahorse-compatible client can read that definition and do all of the binding. Now, I had to specify the endpoint and whatnot, but I mean, you'd have to do a little bit more to provide your auth scheme, but all of these tools are pluggable. So with very little amounts of code, and you get other things like output table. So it's kind of cool. Okay, let's take a look at the next one. So right over here, what you're looking at is actually a sample script written with the Node SDK. So this is the production shipped Node SDK. And essentially what you're doing is we're requiring the libaws module because it's installed locally, and then we are loading up you see that path right there at the top. That is the path to the Seahorse newsfeed service that I generated. And then I'm actually defining a new service. And then from there, I'm going to call a couple operations. I'm going to call get user and get post. So if I were to node sample, there we go. And it just works. This is another Seahorse compatible client. This is let me try it right here. What you're looking at here is the unshipped AWS SDK v2 core. It's still a work in progress. We are pulling things actively out of this and merging into the production SDK. At some point, we'll jump to use Seahorse models directly like we were doing here. But same thing, I'm reading in that JSON file. I'm doing a little bit of translation on it, and this translator actually is shipped with Seahorse right now. But it's doing some inflections, because in Ruby, we love our snake-cased symbolized, parameters and everything. And so in this case, I'm just defining a new service, calling it newsfeed. So if I were to fire up IRB, get user. There we go. And it works for all the different operations. Like I can create post, username, post, body, ABCXYZ. I think that was the, yep, that was the signature, and it returns the post. And if I wanted to tag it or, to get that post, voila. And these are really cool, things, but all of these things, all of these great benefits that we are gleaning from this all come from the same concept of we have a document that describes our API. If you do not have a document, a strong document that's in version control that defines your API, you're missing out on a lot of these things. Now, I'm not necessarily promoting that, hey, you should use Seahorse. It's not production ready. We've got a lot of things to do before we could conquer the world using Seahorse. But the technology there is real. It's easy to apply. It's basic, inflection on a described model of your service. So as I said, there's a lot that's missing. So what are some of those missing stories? Things that we could do with this Seahorse API that we're maybe not doing yet today. One of the things that we'd like to add to it is a strong concept of describing how to enumerate and paginate. One of the problems of using a web service API is it's difficult to deal with. I made a request and I got some response back, and the response indicates that there's more data to get, some opaque next token or some paging information, and you've got to keep fetching until it's done. That's something that you could describe. You describe the parameters on how to get the data out, those next tokens, and where it goes back in on the next request. You can also describe what the interesting bits of data in a response are so that you can make your responses enumerable and get that data out. Another problem working with AWS is you have this problem of eventual consistency. This is not just a problem with AWS, but it's a problem across a lot of things, where the web service responds back and says, here's your identifier, but that resource may not be ready for some time. You could use the Seahorse DSL to describe what those stateful transitions are, what those final states are, and what those terminating states are to stop, to know when your resource has made it to that ready state or when it has failed. And now you can, in a programmatic way, pull for additional information. You could also use the same DSL to build strongly typed clients. So you could, for example, create one Ruby struct for each type in your application. This is a really novel idea because, first off, structs are faster than hash-based access for getting at your data. They give you better feedback when you try to access something that's not a possible property of that struct. Whereas if I fat finger the key on a hash, I just get nil back. And that doesn't tell me that if the property was nil or if that property did not really exist, or would or could never exist. They're also something that you could document, so you can have better, more focused documentation that's not as deeply nested. You could also use the Seahorse DSL to configure retry logic, metadata on what type of responses you might get back that should trigger retries, throttling errors or temporal network errors. I mean, there's all kinds of interesting things you could do there. Where can I get Seahorse? If you want to check out the tech demo and any of the stuff there, I kind of glossed over it. I didn't have lots of time to go into deep details. You can go to GitHub right now, AWS/Seahorse. You can also gem install Seahorse if you want to give it a spin. As I mentioned at the beginning of my talk, this stuff really is not new. I'm sure most of you in this room came to here thinking, gosh, this sounds a lot like, maybe Grape, Rails API, Rocket Pants, RESTful, Apache Thrift, Swagger. All of these things have some or many of these concepts. They do them, same but different. Again, my takeaway that I want you to have is your models should be first-class entities, not side effects. If you're building your application such that your API is not something that you can, diff from one change to the other, then, why aren't you? So that's all I have today. You can find me if you have questions that you don't get asked me today, reach out. Also, a real quick pitch, Melissa over here in the front row, she's our AWS recruiter. We have lots of open jobs, and we are solving interesting problems every day. So if you enjoy working on open source or building tools for other developers, please take a look there and talk to Melissa. She'll be at our booth. Thank you very much.